Assalamu alaikum wa rahmatullahi wa barakatuh. Hello dear students, how is it going? In our lesson today, we will keep going talking about the electrochemistry. Specifically, we will discuss the electrolysis process. But firstly, we need to know some basic information about the electrolysis or the electricity itself. What the first question we will answer, what is the nature of the electricity? What is the nature of the electricity? The second one, which is how electricity transfers through the medium. How electricity transfers through the medium. When we answer those two questions, that will be easy to understand the nature of the electrolysis process. So the electric current, it's about flow of a charge. When we have a flow of a charge in a definite conductor, it will make us or resembling us an electricity or an electric current. So a flow of free charge resembling us electric current. What about the free charge? It may be electrons, maybe the free charge is a free electrons, or maybe free ions. Even electrons or ions, both of them are charged. So what may be the source of those free electrons or free ions? Let's see. Looking to the nature of the metallic crystals, we have here a metallic crystals. We can say it's from sodium elements or sodium metal. We can see the sodium exists in the cation in E positive, localizing by its outermost electron. The outer electron or the valence electron of the metal localizing or existing at the free case surrounding it. This case resembling us a free electron. The first condition, a free electron exists in a material, so it can make easily a flow of negative charge. So we can call the metal elements as electric conductors because it contains a free charge of electron, can make a flow of a charge in this conductor and resembling us electric current. That is the first source of electricity or making a free flow of negative charges of electron. The second one, it's ions. How I can find the free ions? How I can get the free ions? يعني كده بنقول logically from the ionic compounds. We can find the ions from the ionic compounds, but in a conditions. We have the ionic compounds. Most of the ionic compounds are exist in solid states as a crystal salts in a solid state, but the ionic in the solid state don't give a free ions. Ionic compound in a solid state don't give a free ions like sodium chloride in the ACl. Sodium chloride exists in a solid state as a crystals only. But when we make a solution from it, sodium chloride or molten it, we can here have a free ions or a free charge of ions. Opposite to the covalent compound, which is can't give us even in a solutions or in a molten case any ions or free charge. The covalent compound don't give us even in a molten or solutions any free charge or any ions, so it's a bad conductor compound. So what's about the electrolysis? Let's learn some concept about the electrolysis here. Before we study the electrolysis process, we need to know the classification of material concerning to the electricity. We classify the metal or the solid matters in our universe into two types, even it's conductor, electric conductor or not. We have electric conductor, solid substance. I talk about the solid substance or insulator. We have insulator material. In electric conductors, we have a good conductor or a bad conductor. It's a degree of conductivity. That's concerning to the solid matter. Good conductors like the metal and insulators like the non-metal. But also we have some liquid and solutions which can also conduct electricity or not. When we talk about liquids or solutions, We also have two main categories concerning even it conduct electricity or not. We have electrolytic solutions. Electrolytic solutions. What is the meaning of electrolytic solutions? It is a solutions or liquid which is conduct electricity, which is allow electricity to transfer through it, or non-electrolytic solutions. So electrolytic solutions, so it can't allow electricity to pass through, it don't conduct electricity through it. Like in this, when the light is bulb, the bulb is light, it's meaning that the solution or liquid can conduct electricity easily. So it's electrolyte solutions. But in this case, the solutions don't conduct electricity. Let's back to this example. What can you conclude is the nature of this liquid or the solution? What about your imagination about the nature of this solution? Even it's ionic solutions or covalent solutions? Yes, correct. Definitely it is ionic solution or even molten. It's ionic solution, aqueous solution, or even ionic molten, because it allow electricity to pass through, because it definitely contain a free charge to can conduct electricity, a free ions. But that may be covalent solutions or molten like the wax covalent solutions or covalent molten which don't conduct electricity. So when we find in a liquid or a solution which conduct electricity, definitely for the ionic compound like the NaCl, like we see here, even its molten state without water, we subjected it to heat, it changed into NaCl, NaCl solid state, change by heating into an A positive cation liquid state, and chlorine anion, it is liquid state also. But when we hydrolyze it in water, it also will ionize, but in aqueous cation, Na positive change into aqueous, and chlorine also change into aqueous solution. So we need also, before we study the electrolysis process, to know the main concept or the main terms which we will use in this process. What is the structure of the electrolytic cells? What is the structure of the electrolytic cells? The first one, we have here two electrodes. We have two electrodes resembling the electrolytic cells. And the third terms, which is about the electrolyte solution. First electrode, which is called anode. Second electrode, which is called the cathode. And the electrolytic solution or the electrolyte. What about these terms and why we need those three substances or three parts to make a successive electrolysis cells? Electrolysis cells meaning that we need to separate something. We separate compound by using electricity. That is the meaning of electrolysis. Electrolysis meaning to separate something by using electricity. Separate some things by using electricity. So by knowing that the concept of electrolysis, it is separating or breaking of the ionic compounds into simpler substance. We can use the electrolysis in this terms or in this function to breaking up or separating substance, ionic substance, by using electricity, to force them to separate by using electricity, and to allow the electricity to make this job. We need a conductor material. We need a conductor material in this process. The first one will be the wire, which is conducted the battery or the electric supply to the two electrodes. The negative will conduct it to an electrode, and the positive pole will conduct it to another electrode. And the second conductor will be the electrolyte exists in the electrolytic cells. We need electrolyte to allow the electricity to transfer from the first electrodes to the positive to the negative, the positive to the negative, and to complete the circle and electric current can pass. We will discuss in a brief how it can this process happen, but we need to know the main structures of the electrolytic cell. We need a battery to make electric current can pass through the two electrodes. We conduct the positive pole to one electrode, make it will be anode, and the negative one to another electrode, which make it cathode, and embedded both of them in a container containing electrolytic substance. The electrolytic substance may be molten ionic compounds or even aqueous solutions for it. So how the transferring electron happen in this electrolytic solution or in this electrolytic cells? When we conduct the positive electrode to the anode and the negative to the cathode, what will happen? Let's say that the anode is zinc. We choose that the anode will be the zinc matter and the cathode will be copper. The zinc contain in normal state number of positive equal the negative charge as an element. And the copper also in elementary state contain positive charge equal the negative charge. But here, when we conduct a positive pool of battery to the zinc, we force the zinc here to be positive. احنا هنا بنفورس the zinc to be a positive ان هو to release its electron بقى. How the zinc will be positive? It will release an electron. When this electrode of zinc contain positive equal negative, positive equal negative, and it's on. Positive equal negative. So when we conduct it with the positive pole of the batteries, that forces the electron to release from the zinc and flow in the wire of the conductor, transferring to the other parts, which is the copper. And here, after time, the zinc will be, it will can a much positive charge than the electrons, and the copper after time will contain much negative charge than the positive charge. So after time, the zinc will be positive pole and the copper will be negative pole. That is the mechanism of transferring electrons through the electrolytic cells. Let's repeat it again. Let's imagine that the anode is a positive, is in a metal elementary state. We know that positive equal negative in any element, stable element. That's before we conduct the battery. The copper also containing positive equal negative, positive equal negative. But when we conduct the zinc, which is the sampling anode, to the positive pole and the copper to the negative pole, what will happen? What happens is the positive charge of the battery forces the zinc to be positive, forces the zinc to be positive. So it forces it to release its electron, make its electron exist from it, and flow through the wire to can make positive or can to be positive. So the electron transfer from the zinc in a wire to the copper, which be more negative. And so here we have a positive pole and the negative pole. We call the positive pole as an anode, and we call the negative pole as an cathode, or a positive electrode and a negative electrode. And also the electric charge will complete its journey in the electrolytic cell. So we need definitely an electrolytic solutions here. We need solutions which can conduct electricity, which carry a charge, to can flow, allow the electron to flow from the cathode in the solution to the anode in the solution. So that is the passage of the electron inside the electrolytic cells. Okay. As like here, electrolytes molten ore. We can make, or the types of, we can talk about the types of electrolytes. As we said before, we can have it by making a molten from an ionic compound like heat in the NaCl till molten, or make a solution, or can make a solution for it. Both of them will give us a free charged ions which can carry the electric charge of the electric current. What is the example of the electrolytic solutions which can make a free ions? Acidic solutions, alkaline solutions, salt solutions, or even their moltens. So the acidic solutions can move the free ions, alkaline solutions can move the free ions, salt solution also can move the free ions, even their molten. But the non-electrolytic solutions, which is all covalent compound. Covalent compound, not all the covalent, see some exceptions, but most of the covalent compound like alcohol, الواx والبaraffin والorganic substance generally, all of those are a non-electrolytic solution. So this part which is about electrolytic solution. So let's see here the mechanism which the electrolysis process happens. Firstly, I need to mention the relation between the electrolytic solutions or the electrolysis process and the redox reactions. Redox reactions is transferring electron, and electrolysis also transferring electron. So when look at the positive pole, which is anode, and the negative pole, which is cathode, when we need to separate some substance, some ionic substance consists of positive, like NaCl, contain positive parts, which is cation, and negative part, which is anion.